how I feel about that. Okay, so welcome to Sine Law. So we're going to use Sine Law when we do not have a right angle triangle. So we're actually getting into the point where we're giving you new skills. This is brand new stuff to deal with triangles that don't have a 90 degree in it. Can I use Pythagoras in a non-90 degree triangle? The answer is no, you cannot. So Pythagoras, your right angle trig ratios, all of those belong to right angle triangles. When you have a triangle that does not have a right angle, then we're going to move into sine law and cosine law. Okay? Okay, good times. So you can use sine law when you have two angles and one side, and you're trying to find a side. You can also use sine law when you have two sides and one angle, and you're trying to find that angle. You're like, that doesn't mean anything to me, Scallion. I have no hot, sweet clue what you're talking about. And that is fair, because this is brand new. So, if I were to draw you a triangle, no 90 degrees here, I'm going to label my vertices A, B, C. Those have to be done with capital letters, right? So what side is side A? In between B and C, right? It's opposite to where the angle is. So this is side A. Where's side B? Between the A and C. So that's side B. And notice that I'm using lowercase letters to do the B. And then obviously C is the one that's left. So you need to know how to label a triangle appropriately, because if you don't, this won't work. Okay? All right, so here's sine law. Whew. All right, where's the formula sheet? Let me show you where it is, because it's on your formula sheets. And they will be there. So let me grab a formula sheet, a shiny one. Where am I? There we are. There's sine law. Right there. Okay? And we're going to talk a little bit about this. You may see sine law with all the angles on top and all the sides on bottom. It's the exact same thing. It doesn't really matter. So depending on like if you're looking at a website or a video, they may switch these, but they have to switch them on all of them. Okay. So we've got A over sine A. And can I tell you guys that the letters really don't matter? You just need to know. You just need to know that side and angle go inside that fraction together. So if it's x, y, and z, this would be side x over angle x. Side y over angle y. Does that make sense to everybody? Like, the letters are just there as one possible scenario, but obviously we have all different kinds of combinations. We have 26 factorial combinations of letters, just so you know. And again, you could write it the other way. You could have it as sine A over A equals sine B over B equals sine C over C. I usually don't do it this way, because I like the look of this where there's more stuff on the bottom. Don't ask me why. But if you happen to be watching another video, you may see it this way too. I just say that because that's something that you'll do. I'm going to stick to this one, this top one here. So do what you will with that information. And here's the thing. You'll only ever use two. Now, if I call them ratios, is that going to mess you guys up? Ratios is just another word of comparing something. Like a ratio is a comparison against something else. So this is a ratio, and that's a ratio. And that's also a ratio, because you're comparing things, right? So you're only ever going to use 2 out of the 3. Everybody got that? You're only going to use 2 out of 3. So 2 of 3 will be used. I don't know if that's helpful. Do what you will with mine. Okay, all right, big deep breath. We're going to use this for the first time. Okay, so example number 1. From Kelly's house to her friend's cabin is 1.8 kilometers away. So Kelly's house to her friend's cabin is 1.8 kilometers. I don't know why I didn't put that on the triangle, but obviously I didn't feel it was necessary. Kelly wants to know the distance from her house to the store on the edge of town. This should really be right there, sorry. This is what happens when I try to draw things. It gets sketchy. So what side of the triangle am I trying to find? The right-hand side or the bottom? I'm trying to find the bottom. So that's the unknown. All right, so here's the thing. Right now we have no complete information. So I'm going to call these trigonometry sets. That's what I call them, or I'll call them earmuffs. Sometimes I'll refer to them as that. So we need a matching set of information. And what I mean by matching set is the side and its angle. Right? So I call that a matching set. I call that earmuffs, you know, like you have to have both. I use earmuffs more for cosine law. What am I missing? I've got the side here, but I don't have this angle. Can I find that angle? How? You're not wrong. We totally can. Ah, look at you guys pulling that out. So part of us might be like, oh, we got right angle trig, I got some sides, I can find that other side. But remember that right angle trig is for something with right angles. There's no right angles in here. If I want to find this angle here, I have to use something else. And the something else is all interior angles of a triangle add up to 180. So we know that theta is going to be equal to 180 minus 88 minus 66. $26? 26 what? Hopefully degrees. So this is 26. So now that I know that, now I have a set of information. So this is what I'm going to use. This is my trigonometry set because the angle and the side are across from each other. This would be angle S, this would be side S. So you need something that is fully complete. You need one set of information, one full set of information. And so when I'm talking about trig sets, I'm talking about a side and its matching angle. So that's going to be the first bit of information. I'm going to put that as my first ratio. So that's my ratio there. So what goes on top? My side length goes on top. So I'm going to have 1.8 over sine of 26. Now what side am I looking for? The question mark side, right? So what angle matches with the question mark? 88. So this is the other ratio that I need to use. So do I know the side length? No, I don't. I'm going to call it D for distance. I just find using question marks just, I don't know, seems so grade 1. And then on the bottom, we know its matching angle is sine of 88. Okay, so you need one full trig set. Because if you don't use this full trig set, you'll have too many variables and you won't be able to solve. All right, so now we're going to isolate D. We're going to get D by itself. So what I would suggest to you is you do this you don't go to your calculator until the final step, because you don't round until your final answer. Okay, there's a fraction on the left-hand side and there's a single fraction on the right-hand side. We can go ahead and cross-multiply. This is the only place we can cross-multiply. So that's going to be 1.8 times sine of 88, D times sine of 26. That is the act of cross-multiplying. Notice that there is no longer any denominators. Okay? Now I want to get D by itself. So what am I going to do? I got to divide out, right? So please note that this is cross-multiplied. Now I'm doing more math on top of that. So sine of 26 divided by sine of 26. I find sometimes we do so many steps on one line that, and I don't know why I'm rewriting this, I'm just going ahead and doing it, that when we look back at our notes, we're not sure how we got that divide by sine of 26. Okay, so now I'm going to put this all in my calculator. This is not my calculator, but okay, I'm in degrees, that's good. So how are you going to do this in your calculator? I don't know how your calculator works, but you have to do the numerator first. So we're going to go 1.8 times sine of 88. And in my calculator, I can do it all at once, but I would recommend that you get the numerator, get that, and then I can simply go in this one, divide by sine of 26, close my bracket. And what did it say? Let's round to 2 decimal places. So D is going to be equal to 4.10. And what units of measure are we in? Kilometers. That's a long way to the store, just for the record. Okay, can I tell you a helpful... What are you two doing? Why are you hitting each other? It's just trigonometry. You don't have to be angry about it. I'll tell you a handy little trick. Not a handy little trick, but a handy piece of information that we don't normally think about but makes sense. If this is your biggest angle, your longest side will be across from it. And if this is your smallest angle, this will be your smallest side. So that's kind of a way to help you check to make sure that your numbers are reasonable too. You know how we always check that the hypotenuse is the longest side when we use Pythagorean theorem? You can do that here too. So biggest angle, biggest side. Smallest angle, smallest side. So I knew when I started this, if this is 88, it's got to be bigger. I've got to travel 1.8 kilometers. I'll be traveling more than that. So just so you can kind of like check it in your head, make sure your answers make sense. Wasn't too bad. Not too terrible. Oof. Oof. Okay, I love to give questions like this. And the reason why is because I don't have to draw the triangle. You saw how much trouble I had digitally drawing the triangle, so I can just put the information here. And we're going to do lots of these in tomorrow's lesson. Okay, so let's talk about this. Symbol means, what does that symbol mean? Triangle. So the triangle, PQR, what does that mean? The angles are going to be labeled PQR. Everybody got that? So it's just notation. This is the symbol for angle, so it's giving you angle P's degree. And it's giving you the length of P. All right, so let's draw a triangle. I'm going to get really specific tomorrow in where I put my letters. And I'm going to make you follow rules. But for today, we're just practicing using the sine law. So please know that we will get really specific. And if you don't follow my wonderful advice, you're going to end up having problems. So there's my triangle labeled PQR. And now we're going to put the information on it that it gave us. So angle P is 36 degrees. Side P, so remember that's going to be across from the angle, is 24.8 meters. And side Q, so that's going to be across from the angle Q, that is going to be 23.4 meters. What angle is bigger, P or Q? P is going to be a bigger angle. So when you go ahead and solve for angle Q, you should know that you're going to get something less than 36 degrees. It's just a way to help you know if your answer is reasonable or not, okay? It is what it is. Okay, but this question doesn't ask for angle Q. It asks for angle R. So it's asking me to solve for angle R. The trouble is with this one, so this is a two-stepper question. The trouble is for this one is, do I know side R? And I don't know angle R. So there's nothing I can do right now with R. But if I solve for angle Q, can I then solve for angle R? Yes, because then we'll know 2 out of the 3 angles. So it's like a 2-step process. So this is just taking it a little bit beyond. So even though the question's asking for angle R, I got to do something in advance for this. Okay, so what set do I use first? I got to use the P set first, right? Because it's my full set. So I'm going to have 24.8 over sine of 36. And then I'm going to have 23.4 over sine of Q. I do not use units of measure until my answer, because I find it gets confusing with more letters in there than I need. So I wouldn't do that. So what am I going to do at this point? Cross multiply, I like it. So I'm going to have 24 oh, look at that. That's like 2.4.8. Who's in charge of me? Jeez Louise. 24.8 times sine Q equals 23.4 times sine of 36. And again, I just want to point out that that's the end of the cross multiplying. Now we move on into isolating Q. So sine Q is kind of a set right now. So I got to divide out by 24.8 and divide this side by 24.8. So sine Q, and now I'm going to do all that math. So I got 23.4 times sine of 36. And that's going to be 13. You don't have to write this down. You can do it all in one step in your calculator. But for some of you, your calculators aren't nice and they don't store information. I'm going to divide by 24.8. So sine Q, and notice I'm still using capital Q's. So 0.554603828. You have to use all the decimal places until your final answer, okay? How do we solve for an angle? We talked about this, I don't know, it feels like a year ago now. You do that second function sine in your calculator, right? So the notation for that is sine to the -1 . And again, I've got the luxury of a fancy calculator. And I believe the question said to round to the nearest whole degree. So I would go to 34 degrees. But again, that's not the answer to this question. I'll give you a second if you just need to check your calculator and make sure we got the same stuff. I always recommend that you double check that you're in degrees. There was an incident where I loaned a student a calculator on an exam and I gave it to them in radians. It was set up for radians and they did their whole exam, grade 11 pre-cal exam in radians. And there was tears and I felt bad because it was my it was bad. So I always tell everybody to check and make sure your calculator is in the right mode. So the reason why we do these examples together is so that you can check and make sure that you're getting the same answers as me as we go through. Okay, we didn't answer the question yet. It asked for angle R. So we know that, let's try this again. Look at that. How do you like that notation? Theta R. You like that? Or you could just say R, whatever floats your boat. Doesn't matter to me. I just got all fancy and went with a theta. 180 minus the 34 we just found, minus the 36 that we got in the question. 104? I was going to say 110 degrees. And what does that mean about side R? It's going to be the longest side, right? All right, that's it. That's sine law. You're done. 2 examples and you're done.